So hi guys, welcome to another video. So for today's video, we'll be answering the activities in chapter 7, which is IP addressing. So let's start here. So in this activity, it allows you to practice 8-bit binary to decimal conversion as much as necessary. So we should answer this conversion without error. Convert the binary number shown in the octalet to its decimal value. So we have our position, the 1, 2, 4, 8, 16, 32, 64, and 128. And we have here the binary number. So here you'll just add the position with one binary. So we will use some calculator for us to compute the answer here in decimal value. So first we got 128 plus 64 plus 32 plus 8 plus 4, and that's all. So let's see the answer. So the answer is 236 because we just add 128 to 64 to 32 and 8, 4, and the answer is 236. So let's check if the answer is correct. So that's correct. So let's try again a new number. So here we got 64 and 32 and 8. We'll just compute this 3 and that will be the answer here in decimal value. So let's see, 32, 64 plus 32 plus 8. So the answer is 104. So let's check if 104 is the answer here in binary. So that's correct. So that's just an easy activity here in converting binary to decimal. So let's proceed to the second activity here in chapter 7, here in section 7.1, and the conversion again. We got decimal to binary conversion. So this allows you to practice decimal conversion to 8-bit binary values. And we should work this tool and you'll able to do this conversion without an error and convert the decimal number shown in the decimal value row to its binary bits. So just like what we did in the first activity, we'll just add the positions and find the answer here in decimal value. So if the number here in position, if we use the number here, we'll just put 1. And if we didn't use the number in position, we'll put 0. So our decimal value is 46. So we need to use calculator to solve, and I think that's 32 plus 8, 40, and we got, and we will use 4 plus 2. Oh no, 32 plus 8 plus 4 plus 2. So the answer is 46. So the number that we use is 32, 8, 4, and 2. So the other number here in position that we didn't use, we'll put 0 on it because we didn't use it. So let's check if the answer are correct. So that's correct. So we just convert a decimal to binary. So let's try again for a new number, and we got 44. So the values here again is from 40. So let's check. We got again 32 plus 8. Oh, we will just use 32 and 8 because and 4 because here in our calculator we got 40 and I thought it's 40. So there's a 4, so that's just easy because I'll just add 4, so it will become 44. So for the other box, we'll just put 0 on it. So let's check if the answers are correct. So that's all correct. So we just convert decimal to binary. The decimal value is 44 and this is the binary. So let's proceed to another activity. So let's proceed to another activity here in chapter 7. We have the A ending to determine the network address. So use the A ending process to determine the network address in binary and decimal formats. So we have here the host address, the subnet mask, host address in binary, subnet mask in binary, and we will be determining the network address in binary and the network address in decimal. So here we will just copy the host address in binary. We have 1010110, and for the second one we just also copy the host address in binary, the 0001111. And for the network address in decimal, we have 172. We just copy the host address and we have here 31. So here, if our subnet mask in binary is 111111 and we will just copy the host address here in network address in binary. So that's 11000110. So here we will just determine if there are similarities here in host address and the subnet mask. If there is a similarity, we will just put it here in network address. So we got 0010100. So we'll get the decimal value of this binary. So we got 1, 2, 4, 8, 16, 32. So 32 plus 8 is 40. So the answer here is 40. So the same thing here in binary, we'll just get the answer. So we have 128 plus 64 plus 4 plus 2. And the answer is 198. Same here in the host address. So we got 198. So let's check if the answers are correct. Oh, I forgot 0. So let's check again. I forgot the 0 here. So that's correct. So I think we should try again. Try another number. So we will just copy the host address here in network address in binary. We got 00001010. And we'll just copy the host address, which is 10. Same here in the second network address. We have 00010011. And the value is 19. So here, just what I've said, if the subnet mask has 111111, we will just copy the host address here in binary. So 01011111, and the next one is if there are similarities here in host address and subnet mask, we will just copy here. So we got 0111 0000. So here we got 95 for sure because it's the same host address in binary. So here we will just minus this, or we will just compute just to make sure. We have 64 plus 32 plus 16, and the answer is 1, 1, 2. So let's check if the answer is correct. So that's correct. So let's proceed to the next activity. So here is our next activity. The fourth one is this one. So we'll just search for the correct IP address and we'll just click the PC that has the same IP address as shown here in the box. So let's start. So we get this one, same as here. So we get the correct answer because the IP address that's shown here are same here. So this one is because it's the same group. So that's all. And we proceed to the next activity. So here is our next activity in chapter 7. We have in section 7.1, the pass or block. We'll be defining if the IP address is public or private. So let's start. We'll just press pass or block. So pass, that's pass. If the IP address is 192, that must be blocked. So if the IP address is, that is not the same as the 192, that must be blocked. So in this activity that we get 10 points, we got the different number, not just for the 192, it's different. So that's all pass. So let's proceed to another activity. So here is our next activity in 7.1, the public or private addresses in IPv4. So this is the explanation here in the previous activity that we answer lately. So the public will be 0.9.165.201.30. The next one is 64.104.0.2, and the last one is 192.0.3.15. That's for the public, and for the private we have 172.16.35.32, and we got 192.168.35 and 192.168.11.5 and 172.16.30.30, and last one we got 10.55.3.168. So let's check the answers are correct. So that's all correct. So let's proceed to another activity. So let's proceed in the next activity. We got this, the IPv4 issues and solution. So the first description is 128-bit address and 340 under Cillian address. So that will be IPv6 because it's the higher bit address. Next one is we got 32-bit address and 4.3 billion addresses. So we got IPv4. So next one is it transports IPv6 over IPv4, so that will be tunneling. Next one is it uses NAT64 to convert between IPv6 and IPv4. So that is translation. And for the last one, it allows IPv4 and IPv6 to coexist on the same network segment. So that will be dual stack because of coexist on the same network. So let's check if the answers are correct. So that's correct. So now let's proceed to another activity. So let's proceed to another activity here in chapter 7, the IP addressing. So here we'll be practicing IPv6 address representation. We'll convert the IPv6 addresses into short, omit the leading zeros, and compressed forms. Use the numbers at the bottom of the page to continue this activity. So we have the preferred format, and for the first 4 numbers, we'll just copy here in the first box of omit the leading zeros. So for the second numbers, we got 4 zeros, and we'll just put 1 0 as a representation of these 4 zeros. And if we have the first number is 0, we don't include it here in omit leading zeros. And next one is 1 1 1 1, and the next 3 numbers are the same with 0 N0, N0, and we'll just put the representation of each number. And again, if the first number is 0, we don't include it here in this the leading 0. So for the compressed format, we'll just copy this omit leading zeros and we'll put 2001 colon 0 colon dv8 8 colon 1111, and we got here the 3 zeros, so we don't include these 3 zeros here, just leave it blank, and we'll put again another colon and we'll put the last numbers. So we got 2001 colon 0 colon db8 colon 1111 and colon and another colon and 200. So let's check if the answers are correct. So that's correct. So let's proceed to another activity. So here is the next activity. I have identifying the types of IPv6 addresses. So it's a unique internet routable for dynamic or static. Static will be global because of internet routable, and next is will be the link local. Next is for the global again. Next is over 64, the network portion of the address, and next is the link local. So let's check if the answers are correct. So that's all correct. So let's proceed to another activity.